This topic is variation and function. So first you can see the direct variation. And you can see the values here, x from 1 to 5 and y from 2 to 10. You can say that y equals 2x, and this is called the function, because you can see the pattern that the y is always the twice the value of the x. And when you graph them on this Cartesian plane, when you plot the points and connect them, gives a straight line. And the line is through the origin. So when you have a line through origin and it's a straight line, you can say that it is directly proportional. So you can say that y equals kx, or y is directly proportional to x. They're just the same thing, and you can denote the directly proportional with this squiggly symbol you can see here. There's some called gradient, which is basically the k value you have from the direct proportionality. You can have non-linear variation or function. So you can see y equals 2x squared will be plotted like this with a curve. And y equals root of x will be plotted like this here. And then you have inverse variation. It is when y is proportional to 1 by x. We can say that y is k divided by x. So this is called inverse proportionality. Y is inversely proportional to x. And you have a lot of functions here. You just have to know like which shape is which. So fx equals x to the power of 0, which is just a constant, will be a straight line, and it doesn't have a gradient. I mean, the gradient is 0 here, so it's not tilted as a straight line. Then you have fx equals x to the power of 1, that's just a straight line through the origin. Fx equals x squared, you have this curved line through the origin, and this is actually called a parabola. And if fx equals x cubed, you have this half flipped parabola and half parabola here. And then if fx equals a to the power of x, you have this graph. This is called a exponential function. And then you have your inverse function graphed here, and then fx equals 1 by x squared here. And then you can see from exponential function and inverse functions, the line is reaching the axis, but it's never meeting the axis. So this is called the asymptote.